Hello. So, we are into module 9 of the NOC course in symbolic logic. I have already introduced you to the connectives of the PL, and we are going to do in module 9 symbolization with the use of the connectives. So, we are going to learn, this is our first lesson in symbolization. So, we are going to first understand what the propositional variables are, what propositional constants are. Remember, this is syntax, so there is going to be certain guidelines for what to use and what not to use. And ultimately, our goal is to learn how to symbolize with the PL connectives. So, that is what is in on the agenda for today. But before I go and start talking about the symbolization, let me just quickly find out whether and how much of the discussion on connectives you remember. So, we will start with a small and simple problem. Suppose I tell you that we do not know anything more than this, that we know that the proposition A is true, proposition B is false, proposition C is true, and D note is unknown. All right. So, these are what is given, and then I am going to ask you what can you tell me about the truth value of, say, this compound proposition. This is B dot D horseshoe, A dot C horseshoe, B weight C. This whole thing is the consequent and this is your antecedent. So, plugging this value, can you tell me what is going to be the truth value of this? I will give you a minute to think about. Remember, A is true, B is false, C is true, and D is unknown. Some of you, I am sure, have already figured it out, and some, in case you are in trouble or in case you are like little bit confused, I am going to explain this, but this should tell you how much you remember from the previous discussions of the connectives, because unless you know how the dot works, the horseshoe works, and the wedge works, you can't really do the computation of the truth value of this compound. So, if you recall that, this is actually a taste of that knowledge that we have already discussed. So, what is the truth value of this whole compound? Can you tell us? The answer is yes, we can tell, because these are all truth functional connectives and we can figure out only if we can compute the value of the components. So, the answer is computable. Then the question is, what is the truth value of this compound? Now, there are more than one ways to do this answer. But no matter which method you follow, the answer is going to be the truth value of this compound is going to be always true. Now, let us see how. I will explain. See, though I understand you will say that D is unknown, but even if D is unknown, there is a way to find this out. For example, if you start at the antecedent, see, B is false and D is unknown. No matter what the value of D is, B is false, therefore, B dot D is going to be false. And once you know that B dot D is false, you can say that the whole horseshoe proposition is going to be true. Why? Because horseshoe with false antecedent is always true. Now, this is one way to go about it, the antecedent you figured out. Those of you who are saying, but D is unknown, how can we even know the value of that? The question is that, first of all, even if it is unknown, remember the system is such that it believes in only two truth values. So, either D can be true or D has to be false. So, that is one way, that is one answer right there, that D is unknown does not mean that it is completely unknown. You can still make the possibilities clear. The other thing is that you really do not need to know what the value of D is if you are following this kind of method to figure out the value. Or some of you may have looked here, B with C, both are known values. B is false and C is true. If that happens, then B with C, the way it works, disjunction, it is going to be true. And when you know that any horseshoe statement with a true consequent is going to be true. So, this is true, and which happens to be the consequent of the whole compound proposition. So, if the consequent is true, then same logic applies to this horseshoe, the whole compound is going to be true. All right. So, this is one way to figure out how you can know that the sentence has to be true from the given values. As I said, this is just an exercise, sort of a reminder to yourself whether you know the meaning of the connectives that we explained earlier in terms of their truth tables. So, that is the test that was about. If you think that you are still unsure, I suggest that you look it up, that you come to know about that as confidently as possible. Otherwise, the more we progress towards this PL system, you are going to be slightly unsure about your moves. So, that was our first round. But as I said, our goal is to learn how to do the symbolization today. When you are going to do symbolization, my first step would be with the scope of a connective. I have introduced already the connectives. You know that there are 5 connectives, but the point is that the 5 connectives are actually at par. There is no weightage, there is no relative weightage by which you can say this connective is going to rule over the other connectives. It is not exactly like algebra. So, all connectives are at par. Therefore, there has to be other mechanisms to know which one to compute first, which one to do it save for the later, and so on and so forth. And for that, the concept of scope of connective is going to be very, very handy. What is scope? Scope here means the range of legitimate operation of a connective. How far can it legitimately operate on? What is its power? What is the limit of its power? That is what scope indicates. Now, if you are dealing with unary connectives, remember these are the ones that can pick up at most one proposition when it is connecting. So, there is only one unary connective, that is your tilde, and the tilde, the way it works, its default scope is only up to the adjacent proposition. So, up to the next proposition, unless there is some other indications in the proposition. All right. So, let us see what we mean. So, suppose you find tilde p, that is a unary connective. As I said, default is that the scope starts from here and it goes only up to the adjacent proposition, which is p. So, the scope starts here and it ends here only over p. Now, you compare that with say this statement. This says tilde and then there is a bracket or parenthesis starting. Within the parenthesis there is p triple bar q. Again the same logic applies, that the scope starts here, it goes up to the adjacent proposition. But here the adjacent proposition is not single p. The adjacent proposition, because of the presence of the parenthesis, is p triple bar q. So, the range of this tilde will start here and it will go till the end of the proposition. That is what this parenthesis does. It indicates that the tilde scope goes over the entire thing within the parenthesis. Okay? So, this. Now, if we had missed out doing the parenthesis and we just left it like this, that is an important lesson for you also. Suppose we do not use the parenthesis here and we just leave it like this, then what happens? Then the answer is that this tilde, the range of it will start here, it will go only up to the adjacent p. It will not range over the whole proposition. So, what you have? We have two completely different kind of propositions. This one is a negation. Its main connective is tilde. Remember, main connective means the one with the largest scope. Whereas, here you are dealing with a triple bar proposition. Why? Because the triple bar, the dyadic connective, the range starts from here, it goes up to here. The tilde is only starting here, it ranges only over the p. All right, and the truth tables will differ, the meanings will differ. Therefore, you need to understand this scope very carefully, and wherever possible, if you want to mean it in a certain sort of way, use the mechanisms called the parenthesis or the brackets. Now, talking about the binary connectives. So far we saw the unary connective. Binary connective means that they are going to connect 2, at most 2. By default, the range of the dyadic connective is going to be over the 2 components, unless you indicate it in a different sort of a way. So, let us take an example. For example, here L wedge C. Because wedge is a dyadic or a binary connective, no need, if you want to this to be the main connective, no need to have any parenthesis, because default is that it will go over the both the components that it is connecting. Now, suppose you have more than 2, and this is where you will understand why it is important to indicate the scope. See here, for example, you have M wedge L wedge C, same connective, but you need to remember that each well or V is a dyadic connective. So, at a time it is going to only pick 2. Therefore, there is need to group it in such a way that you have ultimately you have 2 disjuncts. So, here is this wedge and this is where the range ends. It goes up to here and it goes up to here. This one on the other hand is the main connective, but here is a disjunct and the whole thing here is a disjunct. Okay. Now, many of you will think that, but the truth value is the same, why do I need the parenthesis? Please remember that what you are talking about here is the emphasis, how we are disjoining it. We are saying here either M or L with C. So, the emphasis is that this is my one option and the other option is an either or. If you regroup it in a different sort of a way, for example, if you want to put the brackets here between M and L, and you say either M or L or C, the emphasis is different and the meaning also changes. Therefore, remember the grouping is important. This on the other hand, you are dealing with 2 kind of connectives. Here is a wedge, here is a dot, and you need to indicate which one is your main connective. This one is a conjunction. So, here is a conjunct and then there is a other conjunct which happens to be a disjunction by itself. So, this is how we are going to read. What we will not allow syntactically is to leave this kind of sentences standalone. Though it is the same connective, if you do not indicate what grouping you are intending it for or which 2 are the disjuncts, then just by itself this is going to give you a syntax error. Therefore, the mechanism of using the parenthesis is going to be quite important for you to learn at this point. Now, main connective, I have already mentioned this, but let me take examples so that we are here. Whenever you have more than one connective in the statement, remember the main connective is the one that I said will have the largest scope. So, the subsequent connectives are going to be sub connectives, but the one which has the maximum scope within the proposition is going to be the main connective. For instance, here as I was saying, if you group it like this and the brackets are here or parentheses are here, then what you are indicating, this is your main connective. Though the wedge is here, the wedge is here also, please note the range of this wedge, as I said, starts from L, ends with C, that is a sub connective. This one on the other hand has a larger scope. It starts from the M, it goes all the way over to the end of the proposition. Hence, this is your main connective. Let me take another example to make this point clearer. Say here, there is tilde, there is triple bar, there is dot. Which one is the main connective? The answer is the tilde. Why? Because every other, if you take every other connective, the tilde has the maximum scope. This dot, it ranges over B and ends with K. This triple bar, it starts with G and ends with this sentence, but this tilde, because of the way we have used the brackets, it starts from here, beginning of the proposition, and goes until the end. So, this is how to understand what is your main connective. Why knowing main connective is important? Because soon we are going to go and talk about truth table and other things. You will see that the main connective holds a primary position. How we understand, how we approach the proposition, you will see that the main connective tells you what kind of a proposition you are dealing with, what truth table you are going to use, etc. So, at this time, please pay attention to the main connective, how to understand the main connective. Now, we are in a position to talk about the propositional variables. Remember, we said we are going to understand the propositional variables. So, here we are. Variables, I am sure you have been exposed to the idea of variables earlier. If not, there is always a first time. What variables are placeholders. Placeholders, they hold a position, and there is no some other thing can go into that place. So, they just occupy space. When you want to use this kind of variables with propositions reference, what you are doing is making a non-specific reference to propositions. You do not mean a particular proposition like today is Tuesday or something like that. You just have any proposition when you want to talk about any proposition. Then symbolically we say, this is case sensitive, choose lowercase alphabets. Lowercase alphabets towards the end of the alphabet series. In fact, we choose P, Q, R, etc. Please note, I am going to remind you again, the lowercase. So, if you are using propositional variables, symbolization might work like this. Say, we want to say for any two proposition P and Q, any proposition P and Q. Suppose we want to say P does not imply Q. I have already introduced you to the connectives. How to read this? We are talking about given any two proposition P and Q, it is not the case that P implies Q. So, the translation is going to be tilde, it is not the case that P horseshoe Q. All right. Similarly, when we are saying P implies not Q, again we are using propositional variables, not actual propositions. What we mean is that P implies that it is not the case that Q. So, P implies if P, then it is not the case that Q. P horseshoe tilde Q. You can try this yourself, so that your grasp over symbolization grows a little bit. Here is another kind of translation. See, P is equivalent to not Q. P is equivalent to not Q. So, the main connective is this. P is equivalent to not Q. So, here is P triple bar tilde Q. Which one is the main connective? The equivalence or the triple bar. Last one here, P is not equivalent to Q. Very different from what I am saying here. What am I saying here? It is not the case that P is equivalent to Q. Try to read it and you will see why the translation has to follow in this way. It is not the case that P triple bar Q. The tilde attaches and rules over the entire sentence. So, take a look, the main connective here is the tilde, the main connective here is the tilde. In order to indicate its large scope, we need to use this parenthesis. All right. Let us now move to propositional constants. So, propositional variables we saw what they are and how to work with them. Remember the lowercase alphabets towards the end of the series. Propositional constants on the other hand are like numerical constants. Within the context, they refer to one specific proposition. So, they remain constantly referred to some actual proposition. Symbolically saying, we need to use capital letter, and with respect to the proposition, you will see soon when we go into actual problems, that we need to find a suitable capital letter, something that reminds you of that proposition. But the point here to remember that you need to use capital letters. So, something like A, B, the inverted commas are not required, but this is capital letter that you need to. So, if you are using capital letter, we understand that you are referring to actual propositions. If you are using lowercase, we know that you are talking in terms of variables. So, case sensitivity is something to remember by. Here is example of symbolization with propositional constants. Suppose we have, if Bangkok is in Thailand, then Bangkok is in Asia. Here is a proposition, here is a proposition. And because these are actual propositions, we will pick up capital letters. and suitable capital letters in the sense that in order to remind us we are talking about this proposition which has Thailand in it, we chose the T, capital T. This one has the reference to Asia, so we have chosen capital letter A. This is an if then sentence. So, very easy to understand that the main connective is going to be horseshoe. So, this is how to read, and then once you are practiced, this is the translation that should be of that proposition. But remember, these are all constants and you are talking about T horseshoe A as the symbolization for an actual proposition such as this. So, in general therefore, how to do symbolization in PL, and we will see more symbolization in the next module, but remember that first of all you need to choose the statement symbols. If the key is already given in which symbols are mentioned, then your job is done, you just follow those symbols. But the main point is whether you are using variables or constants. By now you should know what we are talking about, and there is a difference. But most of the time along with the problem you will be given the statement symbols to use for, with clear indication what the symbols stand for. Once you have the symbols, then read the statement carefully. Why? So that you can identify the connectives, especially what is going to be the main connective. There may be sub connectives also, but this symbolization means you are translating from one language to another. So, there will be English words, and then you need to figure out what will be the corresponding PL connective to use in place of that English word. That is going to be how the symbolization is going to be done. And the thing is finally is that once you have chosen the appropriate connective in each case, remember to check its scope, because if there is an error to approach the scope, you are changing the meaning of the proposition. Your job is to translate, not distort, not completely change the meaning of the proposition itself. And the grouping of the components is going to be important also, and this is what you learned in terms of use of the mechanisms of parenthesis. So, how the intended proposition is meant, that grouping you have to sort of keep as is. Once this is done, then we are in a position to talk about the actual symbolization. So, I am going to try out certain things with you. Here is an English sentence. Mona read the book, but she did not like it. Two sentences or two propositions, and here is the given key. M stands for Mona read the book, L for Mona liked the book. And here is but. This but is to be translated as what? In PL, its corresponding is the and or the conjunction or the dot. So, if you have done that correctly, then the translation is going to be very easy, M dot not L. Where is this not coming from? The tilde is coming from not, did not like it. Remember, the key is Mona liked the book. So, if you want to say Mona didn't like the book, this is how it is going to appear. Here is another sentence. Harsh will play if and only if Mehta and Sridhar are not in the team. All right. Now, as you can see, start reading it with me, so that you can see that there are three components in it. One is Harsh will play, and that is your H. The other one is Mehta is not in the team. There is no sentence called Mehta and Sridhar. Obviously, Mehta is in the team, that is your simple proposition. Sridhar is in the team, also a component. So, M is for Mehta is in the team, S is for Sridhar is in the team. Now, we are in a position to find out how to translate. Which one is the main connective you think? And you will, if you are reading it properly, you will say the if and only if is the main connective. Once you know that, the rest is easy, slowly we will go. So, this is our one of the component H, and then this is going to be triple bar, and here comes the next one, which is Mehta and Sridhar are not in the team. So, Mehta is not in the team, Sridhar is not in the team. Now, how to express that? And you see that you need to translate it like this. One is Harsh will play if and only if, and then you are saying Mehta and Sridhar are not in the team. So, neither Mehta is in the team nor Sridhar is in the team. It is not the case that Mehta is in the team, and it is not the case that Sridhar is not in the team. All right. You need to work a little bit with problems such as this to see how the translation is happening here. Let me go through another example here. This is, we do not need to raise taxes or show deficit if wasteful government spending is curbed. Clear indication that we have 1, 2, 3 components here. But T stands for we need to raise taxes. Remember, usually the key is given in terms of simple proposition. Wherever you have not, you have a compound sentence in your hand. So, T stands for we need to raise taxes, D is for we show deficit, G is for wasteful government spending is to be curbed. And the translation happens like this, that G, if G, then not T or not D. How do we get this if then? Well, here take a look. We do not need to raise taxes or show deficit if whatever. Now, follows if, that is your antecedent. How do we know this is our main connective? Read again, there is a comma. So, it separates out the components clearly. This is your antecedent and this whole thing is your consequent. So, this translation is to be done carefully with this kind of parsing. With that, we are going to end this, but not without giving you a little bit of a help here, is that don't get discouraged in the very beginning that if we are missing out translation or I don't know how to do this, etc. Give yourself a little practice. For example, don't look at the cues I have given. Try to do this on your own and see whether you come up with the same result or not. Sometimes we are impatient in reading the proposition, we just did not get it. We just think that in one reading we will be able to understand it. Not necessarily. So, give yourself a little bit of a practice. Here, for example, if you missed out this if, then you are missing out the whole structure of the proposition. So, a little bit of a careful reading, careful understanding and a little patience in the beginning is going to help you a little. With that, I am going to end this module, but we will come back with more symbolization in the next module. Thank you very much.